The diagram shows a trapezium ABCD. We're told that BC is parallel to AD, and we're told that AD is equal to 3 times BC. So this is 3 times this, which means it will be the vector 3c. We're told that vector A to B is B, which is marked on, and B to C is C. Part A, find in terms of B and C the vector C to D. So we need to find C to D, which looks like that. I know that's going to be the same as C to B plus B to A plus A to D. The C to B is the same but in the opposite direction to vector C, so it would be minus B. Sorry, minus C. The B to A is the same but in the opposite direction to vector B, so it would be minus B. And then the vector A to D is the same as the vector 3C. So simplifying that, then we've got the minus C plus the 3C, which is 2C, and the minus B can't be simplified, so we'll leave that as it is. And so that's my answer for part A. That is the vector C to B. Right, we're then told that the point P lies on the line AC, so P is somewhere on this line, such that A to P to C is 2 to 1. So P is going to be somewhere roughly about here, where A to P is 2 parts and P to C is 1 part. And the question's asking us, is BPD a straight line? Is this a straight line? That's what we need to figure out. Well, if it is, then BP from here to here would be parallel to the vector B to D. So that's how I'm going to decide if it's a straight line or not. Is BP, or are BP and BD parallel? So BP, BD. Let's work them both out and see if they're parallel or not. So B to P. To work that out, I'm going to go from B to A plus A to P. Now the B to A, that's easy, I know what that is. That's just going to be minus B. The A to P, I'm not sure what that is at the moment, but I know it's going to be 2/3 of A to C. And A to C A to C is the same as B plus C. Which would be 2/3 B plus 2/3 C. So that's my vector A to P. So I now got my vector B to P, but I can simplify that because I've got a minus B plus 2/3 B. So minus 1B plus 2/3 B would be minus 1/3 B. The minus 1 plus the 2/3 is minus 1/3. And we've got the B. And don't forget the 2/3 C as well. So that's my answer for BP. Now for B to D, remember we're trying to show whether these vectors are parallel or not to decide whether it's a straight line. So B to D, I can do that by going B to A plus A to D. The B to A, I know that's just minus B. The A to D, I know that's 3C. Right, so we have now worked out our B to P and our B to D. Are they parallel? Let's compare them carefully. Let's look at the B parts of these vectors first. I've got a minus B here, and I've got a minus 1/3 B here. So this is 1/3 of this. Does that work with the C components? Is this 1/3 of this? No, it's not. 1/3 of 3C would be 1C, not 2/3 C. So these vectors are not parallel. So to write my conclusion, I'm going to say BP and BD are not parallel. Therefore, BPD is not a straight line.